Hello, everyone. Bon dia, buenos dias. Good day to you all. I'm talking to you from the San Francisco Bay Area in California. That's where this stream was initiated. And I'm going to probably take my picture out of the loop for the remainder of this talk. So sorry about that, but it just takes up too much screen real estate. My name is Kathy Jory. I work for Zadita, and today my talk is about tackling climate change with open source and data-driven technology. You can see that a number of organizations and open source projects were involved in this case study that I'll be talking to you about today. So first of all, on the agenda is a case study. The focus of the first half of the talk is explaining how this biodigester in a remote location in Chile is doing sustainability of improving climate change by transforming waste to energy with some other beneficial byproducts. And the benefits of open source and industry support were very critical to enabling this technology to be remotely managed and visible and tracked for the truthfulness of their operations. So in the first half, we'll talk about set up the case study. Second half, we'll talk about how we managed to support this project. First, what is biodigestion? I looked on the internet, found a couple of examples where people have tried to either reduce the methane gas emissions or actually collect it from cattle. And cows basically, they eat plants, feed, and water as their inputs, and they produce things like milk, methane, and urine and manure. So this is an example of natural biodigestion inputs and outputs. But we're not really here to talk about cows today. I'm talking about a cow-friendly method of biodigestion, which is this biodigester in Chile that takes in agricultural residue, such as all of the grape harvest residue a couple times a year, all sorts of biosolids from stabilized sludge and grocery store expires, and then manure, liquid industrial waste, organic residue from fisheries and meat processing industries. And this is the liquid down here on the left collection, and these are two of the solid collection sites. And with all these inputs, you get outputs such as liquid fertilizer, mulch, you see a bunch of mulch up here, and methane gas. The entire site is powered by the methane gas that it produces on site. They convert that to electricity, then powers the whole site. So you can see this is a bit more cow-friendly than the previous example. This is a hard to read design, but you can kind of see that there's solids and liquids transports and putting into these bins and so forth. And the takeaway of this page essentially is that there's many different sensors, level sensors, flow meters, measuring weights and the energy produced, and then other manual data that are tracked, as how much the shipments that are received of these bio wastes and the sales and tracking of the outputs of the processing of the biodigestion. And it's really kind of a cool project, if you ask me. So on the left, we have some images or renderings of the project. This is the dry waste facility inputs here, and the liquid waste, I think, is over here. This is an example of a gas flow meter. This is the pressure, one of the pressure sensors. And in these various tubes, they have these inline sensor systems. And here's, you can see some of the pressure visible output. Some of the real pictures over here on the right, including a little overhead. You can see it's in the middle of an agricultural area, so it's very remote location, but fortunately it produces all its own power, so not a problem. And this location is in Molina, Chile, and yet this plant has visibility through this dashboard online from anyone, anywhere on the internet. So they can now track these greenhouse gas emissions, and annual contributions with a data confidence score. So that's what we're going to talk about, is this climate accounting, this method of using open source to track all these things. Digital MRV stands for digital measurement, reporting, and verification. It's a solution that's a standards body kind of type of solution for carbon accounting for these state-of-the-art waste-to-energy facilities, and it supports the finance and carbon markets and these tracking of nationally determined contributions. So the Paris Climate Accord and these types of things. Each nation has some goals for their climate change reduction, and these are national determined contributions according to some standards. So the measurement is based on what the standard body determine is needed to quantify the greenhouse gas emissions. The reporting, there's different types of ways of sharing the results in a standardized and auditable manner. And that verification, the on-site and off-site teams are responsible for quality assurance and control, but there are third parties then that examine the truthfulness of the reported data. This view here, digital MRV and the data confidence fabric solution overview, shows that not all your data has to be electronically automated collected. So the green here is the automation from sensors that are on site, and the gray area of data here are things that they haven't digitized yet. So the feedstock weight and the truck mileage and the material types and diesel and photos, miscellaneous, they're all fed in with a confidence score by the Ovarium server and then tracked all the way through the distributed ledger technology of IOTA with these data plus the confidence, and then they show up on the digital MRV dashboard. That's how they came up with that confidence score at the end. And this, although the project I'm showing today is just one site and one tracking aspect, if you collect all the, we could produce a lot of biodigestion plants, you could summarize this up for whole countries and the whole world, essentially. The ultimate goal is the security and transparency of that data, proving that you're actually producing these methane capture methods. And the greenhouse gas auditor benefits obviously are the automation brings data to them faster, less expensively, with objective and transparent and rigorous analysis. And finally, one more eye chart on the goal of enabling these climate improvements to be profitable. What better way to reduce emissions than to make it profitable for companies, for landowners, for businesses, for agriculture, for everybody to participate in this really necessary need to reduce our emissions and reduce the heating of the planet. So you've got the standards bodies have already done their work, lots of great work. The digital system on site has already been developed. They, according to the standards, they know what sensors and what things to track, and then routing and networking. So stage 2 is measuring and securing those data, piping it over the internet to the digital MRV system, which further exports it for this online verification, tracking, reporting by the auditors. Ultimately, you've got an export of registries, markets, finance reports, and certification that brings it all together. We want the sort of the oil and gas and sustainable energy markets and other types of markets. We want that for the climate improvement markets as well. Now, that was sort of explaining the case study, and then I want to talk a little bit more detail about the use and benefits of how open source at the edge is enabling this project. We start off with Trevor Kahn at Dell. He took one of the Dell T140 PowerEdge servers, installed an installation boot of the Project Eve image, and flashed it onto the USB, booted that Dell, connected it up with the ZDITA remote Eve controller capability, which was really needed for this remote access from anywhere, and then shipped that Dell off to Pablo on site in this remote location, and he plugged in the internet, Ethernet, and a second Ethernet port connected to a private only local network with static IP. So how that works is the ZDITA is in the cloud, and that goes over the internet, over TLS. A secure link is set up between the edge node and the cloud. And then the application, Darrell Chapman of IOTA Foundation, deployed through the ZDITA web user interface his own applications that get deployed to the site via this TLS link. No one else really has access to talk to the box, and in fact the box is completely locked down locally. So you don't need any IT staff locally. And then locally it's connected up over one static IP network to this Historian, PLC, SCADA, some sort of system that pulls in all the sensor data, and the internet connection is used to bring that application data to the digital MRV system. So Eve is running on the hardware. What hardware it runs on doesn't really matter. It's best to have a TPM so you can do remote attestation of the boot and know nothing has been compromised. So there's a lot of great security features to Eve that I'm not going to go into today, but you can check out the project and you'll see how strong, basically best of breed security for the edge. And although many of us on the project would love to visit Chile, Darrell's in Canada and Matt's in Berlin and I'm in California, none of us have been there because we have remote access. Here's an IT administrator would be doing a remote access on the device side, making sure it's up and running correctly and that the software that's supposed to be running is running. And then if it is running, then they'll see all this data show up on the digital MRV side, which is the operational technologist view of the world. And just describing a little bit about the flexibility of open source plus industry is typically at the core, you have things like Project Eve and Alvarium and IOTA Foundation. This is going to be your abstraction layer, your virtualization on the edge, so you can deploy any software to it. Alvarium does the data confidence fabric, SDKs, quantifies data trustworthiness. And the IOTA Foundation transfers and secures that data over the Tangle, they call it, the digital ledger technologies, and it ends up on the digital MRV. On the commercial side, Climate Check and Zadida and Dell are the commercial contributions to this project. But it's really, in any business and industry, you're using core software that's open source whenever possible, and then the business application, the ultimate analysis of things is usually done by commercial enterprises. So Eve locks down the bare metal securely, IOTA secures and routes the data, and Alvarium applies the confidence score so that the auditors know they can trust the source. Now I'm going to pull in a live demo, if I can here, of the site in Chile, of the node in Chile. So let me just click one more here. This is an example. If you're not watching the video and you just see the presentation, you'll see that guy right there. But I'm going to pull up the, let's see, where did I go again? I need my page. Come on. Let's see. Where did it go? Okay, just a second. I lost my window. I need to find it. Z control. There we go. All right, so this is a site in Chile, even though the IP address from ipinfo.io makes it seem like it's in Miami, the ISP, it's actually in Chile, trust me. And the Edge node has a bunch of different pages on it when it's first booted, when it was last rebooted, all of the utilization. It sends the metrics, the logs, all sorts of tracking data periodically, and it doesn't have to be an always-on internet connection. It can go down and come back up and then provide the logs. So you keep track of them, and intermittent networks and so forth and also work. And then it tracks what's running, the applications and volumes that have been deployed to it. The basic info tells you the local IP address of the ETH0 interface is the management interface. There's another interface, ETH1, which is just shared by the applications. It's just an internal network. And you can look up there could be other sensors and actuators that use other adapters. The IT person gets to track all of these things or make policies for all of these things. And then you get auditing of what things were done by the system and what things were done by a person. As you can see, the system is doing most of the changes based on the state of the network. And then what's going on On the application side there's the Molina virtual machine, and Darrell Chapman set all of this stuff up with the applications that are running on it, and you can see its utilization, its network rates. He has remote access over the VNC port on port 5900 in his browser. He could go up here and say, turn on the remote console and have access to it. And then he also gets the events, if he had the remote console start and end, or started or stopped the application, you'd see all of that tracked and logged there. And then the adapters, you see the application has access to both the internal static IP, which is the and this is mapped through the virtualization layer, and then also the internet. And you can see a ton of data goes over the IoT tangle, the IOTA tangle to the internet. Lots of data there. And let's see. And then there's, in general, how Zadida works is he's deployed one of these Ubuntu Cloud application. This is what Darrell deployed. You set up the inputs and outputs of the environment, and there's some custom configuration that was added so he could create a secure login over the VNC. And you can deploy, many different applications at the same time. There was some others here that are tracked, or you can create your own with the library. So some of these were containers that when we first set this up, we were testing with the container itself, but the virtual machine offered a little more flexibility. In the libraries where you set up all the networks, the network instances of the DHCP network and the static IP network. Data stores are where some of these applications can be pulled from. Various Eve images. We use some ones that had some debug scripts that we can access remotely, but normally they're totally locked down. And then some of the app images that are available. And you can set up volume instances that allow the software to be on the box before you even ship it. So that's also useful. In the end, there's reports you can do. My favorite report is looking at network utilization. That's the screenshot I had. And so over the last 24 hours, we can take a look at, you can see when the transmissions were, going out in bulk periodically, where the top talkers are. And then the flow log, you can see where traffic flows, and you can look up, specific types of flows. And some are, domain names will show up, and others are just simply IP addresses. So this is a type of metrics that are constantly being recorded from the edge node by the Zadida system. So that's enough of a look for now. You can also do Kubernetes clusters. None of those are set up right now, but it's all been running happily, and we don't really need to touch it much. So let's go back to slideshow mode here. So again, that was the network flow. And here we're all ready to the summary of the project. In summary, I've got some useful links to show the different organizations involved and hyperlinks to access them. And then that's, the application software and data processing. If you're on the operations side of technology, you're probably interested in these. If you're on the IT world side of technology, you're probably interested in the device and industry support from Zadida, Dell, and Eve. Project Eve is all open source software on GitHub, which is linked to from the lfedge.org Project Eve link. It links to all those other sites. And a summary in a little more graphic form of the solutions and partners is we've got this Dell server running the open source EvoS software. It's managed and controlled only by Zadida's backend system, which anyone has access to for like Darrell and Matt and anyone. Dell helped with them the Alvarium SDKs and Project Alvarium. These are both Linux Foundation Edge projects, and then the IOTA Foundation have been key in the role of this specific biodigester plant, and also working with Climate Check for the digital MRV platform for data confidence integrations. So I'd like to thank all the contributors to the project and thank the audience for listening. And I'm not planning on using my whole time, so I can I'll be online through the internet during the actual live conference, and hope to answer some of your questions and answers, and you can contact me, and just hope you enjoy the rest of the conference. So thanks for joining, and have a great rest of your day.